All right, so for this video, we're going to discuss this persistent bugger problem, and it's a 6 challenge, so it's kind of challenging, but basically what you're doing is it's multiplicative persistence. So if you have a number 39, the multiplicative persistence count would be 3 because 39, 3 times 9 is 27. 2 times 7 from 27 is 14. 1 times 4 from 14 is 4. So you had to multiply it 3 times to get to a single digit number. So if you had 999 before, because 9 times 9 times 9 is 729, 7 times 2 times 9 is 126, 1 times 2 times 6 is 12, and finally 1 times 2 is 2, so that'd be 4. So you're getting a count of how many times you have to multiply the number itself by itself all the way down to a single digit number. That's kind of confusing, but that's the idea. And so what we're doing here is we created this variable here, and this variable here is we're taking the number itself, so whatever the input number is, and we are converting it to a string here. So that's all we're doing, is just we're converting it to a string. Next is we are creating an array based on that string. So we are creating an array of that string, and so it will return an array. So it'll return an array of the numbers. So it will return an array of 3 and 9. And then we are creating we are multiplying those numbers in that array by each other right here. And so what we're doing is that will produce a product, and that product will be, for instance, the first round will be, if it was 39, it'd be 27 would be the first product. But then we have to create a second product. So we have to create a second string that takes the product, now not the original number, but the product, and plugs it in to multiply to a new array. That's the new array is the product of the digits of the next array, of the previous array. And so you just do an array. So you're building an array, you're multiplying the array, you're getting a product, and then you're getting an array of that product, multiplying that array, getting a product, making an array of that product, multiplying the product, getting an array of the product, multiplying the product, all the way as many times as you need to get down to a single digit number. And then at the end, the actual result is we need to check if the original product is less than 10, so it's a one digit number, we return 1. If the second product is a one digit number, we return 2. If the third product is a one digit number, we return 3, and all the way down as many times as possible. We can't, I don't know a way to do this to infinity. There is a way to do it, but I'll just have to manually do it for every possible one all the way down to, because if you get down to product 6 or product 7, it's going to have to be a huge number that you're going to have to get down to that. So if you test it, this works for the first one, but what we're doing is we're creating it for all of them. So what we need to do is check one more thing here, is if num equals 0, return, or if num is less than 10, return 0. So that just says if the number itself you can't multiply it by itself, because you can't multiply the digits because it's just one digit, you return 0. So that's good there. We're going to add product 4, product 5, and maybe product 6. Okay. Now we have to go back in here and do cut that. Okay. Boom. That's 4, 5, 6. Okay, that should cover if the number goes down, has to go from basically that should cover. So if we did 9, 9, 9, 9, so 9, so 9 times 9 times 9 times 9 times 9. That's 1. Oh shit, this could get confusing. What if it includes a 0 number? Oh my gosh. So maybe it only will include yeah, it takes a positive number. So maybe it won't include that. So let's check. So that passed the test. Let's see if it passed the attempt. So we need to go bigger. So I guess it's not including 0 numbers because that would throw it off even more. So this that's 1. That's 2. That's 3. That's 3. That's 4. That's 5. That's 6. Oh, and then that's 7. So we need to do one more for that one. So we need to add 7 and do the exact same thing for that one. Okay, test it out. Works there. Works there. Passed it. So I guess it doesn't include any numbers that have a 0. That the multiplicative persistence includes a 0 as you go down towards 1. So it's all positive numbers, and it's to 7. So all the cases ran to up to 7 places. So seven times you would so 7 instances you would multiply the number by the digits of the number by itself to get down to 1. So if you had 999, it's 9 times 9 times 9. It gives you a number. Do that number times all the digits of that number times each other, and all the way down to 1. You get the pattern. So you're creating, just to wrap it up here, you are creating, you are taking the number and converting it to a string, and then converting that string to an array of numbers, and then multiplying those numbers by each other. And you do that, and then you convert that. Then you take that, convert it to a string, turn it to an array of numbers, multiply those numbers by each other, all the way down 7 times. And then for each of those products, product 1 through 7 that you get, you check if any of those are equal or less than 1. So if the first product is less than 10, then you return 0. If the second product is, or if the number itself is less than 10, return 0. If the first product is less than 10, return 1. If the second product is less than 10, return 2. So you're saying that if it takes 5 times to get to less than 10, then the answer is 5 because it takes 5 times. So that's the idea. Thanks.